So let's talk about adding complex numbers. So we know that any complex number can be represented as a plus bi, and this is also equivalently equal to r e to the I theta, where r equals square root of a squared plus b squared, and theta is equal to the inverse tangent of b over a. So let's talk about adding these things. So geometrically, of course, you can think about the complex number as being basically a set of points on the real and the complex plane, you know, AB, to maintain our notation. So let's say I have two complex numbers, z1 equals a1 plus b1i, and z2 equals a2 plus b2i. Then if this was a1 and a1 and b2, and let's say this is a2 b2, then really all we're just doing is adding them together like vectors. So z1 plus z2 is just the same as a1. Let's go to the next page. So z1 plus z2 will equal a1 plus a2. This will be the real part, plus b1 plus b2. This will be the complex part. So you can see that really adding complex numbers is the same as adding vectors. And really, we didn't need to know the fact that uh, you can obviously say that a we could say something like from our previous notation, we basically had that zn, some arbitrary complex numbers an plus bni. So then, if we said that this was equal to um, Rn e to the I theta n, then we would say that Rn, as before, is the square root of an squared plus bn squared, and theta n is equal to the inverse of bn over an. So then we could represent each one of these complex numbers in this form. So if we had like a z, if we had a z1 plus z2, that would be equal to r1 e to the I theta 1 plus r2 e to the I theta 2. So that's just a different way to represent them, and you could represent these exponentials in one more step as they're trigonometric, because e to the I theta is equal to cosine theta plus I sine theta. So really this form, using this trick that the complex number can be represented as a complex exponential, is more helpful for multiplication and division. We'll see that. So basically, you can think of the operation of addition between complex numbers being the same as doing vector addition, basically. and the same way that, you know, you can think of a complex number as a vector um, in this plane right here, and at everything that you can think about in terms of in terms of vectors can be applied mostly to complex numbers. So in the next video, I will talk about multiplication.